The book problems, water and aqueous systems. What causes the high surface tension and low vapor pressure of water? Well, it's going to be the hydrogen bonding. Hydrogen bonding is responsible for it all. Water molecules are hydrogen bonded to each other, but not to air molecules. Net attraction is inward, minimizing the water surface area. Hydrogen bonding makes it more difficult for water molecules to escape from the liquid phase to the vapor phase. How would you describe the structure of ice? Very cold. Now, the structure of ice kind of opens up relative to water when it freezes. It makes this nice little open structure. Ice has a honeycomb-like structure of hydrogen-bonded water molecules, kind of like in a tetrahedral fashion. Tetrahedral fashion. What effects does a surfactant have on the surface tension of water? It reduces it. Surfactants, like detergents and other things, will reduce it. Surfactants lower the surface tension of water by interfering with hydrogen bonding. Number 4. So try to come up with some ideas for surfactants. See what happens. What are 2 factors that determine how spherical a drop of water, a drop of liquid will be? Well, the first one is hydrogen bonding. That's going to be the major. That's going to be the major one. The surface tension of the liquid tends to hold a drop of liquid in a spherical shape. Gravity tends to flatten out the drop. That's actually quite true. But it's all hydrogen bonding. It's hydrogen bonding. The water molecule and methane have similar masses, but methane changes from a gas to a liquid at negative 161 degrees Celsius. Water becomes a gas at 100 degrees Celsius. What could account for this? Water has intermolecular hydrogen bonding between its molecules. Methane does not. What is the percent of water by mass in copper 2 sulfate pentahydrate? Well, it would be the total mass of the hydrate. That would be the denominator, and then it would be the total mass of the water. So it would be 5 times 18 divided by the mass of copper 2 sulfate pentahydrate, and that would times 100, and that would be 36.1%. Calculate the percent by mass of water in calcium chloride hexahydrate. So you would say calcium is 40 plus 70 plus the quantity 6 times 18, and then 6 times 18, that quantity divided by the first quantity, the total mass of calcium chloride hexahydrate. I didn't really do those calculations because they're very, very basic, and you should be able to do them yourself quite easily. In the formation of a solution, how does the solvent differ from the solute? The solvent is the dispersing medium, and the solute is the dispersed medium. The dissolving medium is the solvent, and the dissolved particles are the solute. Another way of putting it, absolutely fine. Wonderful way to put it. Describe what happens to the solute and the solvent when an ionic compound dissolves in water. The solvent will solvate the solute, but just as individual solute ions break away from the crystal, the negatively and positively charged ions become surrounded by the solvent molecules, and the ionic crystal dissolves. That's solvation. Just remember that not all ionic compounds will dissolve. Why are all ionic compounds electrolytes? Well, I'm not sure that's altogether true, but they do conduct electricity to one extent or another. Some do it better because they dissociate into ions, but not all of them dissociate into ions. Some of them do very poorly dissociation, like mercury 2 chloride or barium phosphate, barium sulfate. How do you write the formula for a hydrate? You write the salt part of it, and then you put a dot and then the number of water molecules per crystal, individual crystalline structure. In writing the formula for a hydrate, a dot is used to connect the formula of the compound to the number of water molecules per formula unit. What's formula unit? Formula unit is a way of expressing an ionic compound. One, you don't say a sodium chloride molecule, you say sodium chloride formula unit. Which of the following substances dissolves to a significant extent in water? Explain your answers in terms of polarity. Explain the following substances. It's nonpolar, so it's not going to really dissolve in water very much. That's methane, C₂H₄. It's organic. Get used to that word, organic. It's insoluble, nonpolar. Methane comes from plankton that was turned to gas over millions of years. Potassium chloride is an ionic compound, and it will dissociate, and it will dissolve significantly. In water completely, it will dissolve. Potassium chloride is extremely soluble, and a very important part of your ability to metabolate certain foods. I mean, your whole metabolism is keyed to ions such as potassium and chloride. Helium is a noble gas, does not form ions. And so, unless it's an alpha particle, I don't even think alpha particles, that's an interesting question. Extra credit if you can tell me if alpha particles do that. But helium is insoluble, it's nonpolar. That's a good question. Does an alpha particle dissolve? Very interesting. Extra credit if you can give me the answer to that. Magnesium sulfate, Epsom salts, that is certainly going to dissolve quite well, actually. So MgSO4 will dissolve. It is soluble and ionic. What's next? Interesting. I think there's 5 problems, 5A through D. But magnesium sulfate will dissolve. I may have to change some of the timings on these. Sucrose, interesting. Sucrose will hydrogen bond, sucrose will dissolve, but it's not an electrolyte. But sucrose, there's a lot of hydrogen bonding with sucrose. If you look at the molecule of sucrose, you see there's a lot of places for it to dissolve, but it does not dissociate. It will dissolve, however. It will dissolve rather well. But sucrose is not an electrolyte. Sucrose will not form ions, and that's not how it dissolves. It dissolves through hydrogen bonding. Sodium bicarbonate, sodium hydrogen carbonate. The bicarbonate ion is HCO3, -1 charge, plus the sodium that is going to be very soluble and very ionic. Okay, let me change the timing and let's get to the next slide. Identify the solvent and the solute. In vinegar, I dilute aqueous solution of acetic acid. Well, the water is the solvent and acetic acid is the solute because it's diluted. It's diluted with the solvent. Acetic acid by itself, pure glacial acetic acid, could be a solvent, but in this case it is not. Distinguish between effervescence and hygroscopic substances. Hygroscopic, well, let's wait for the answer, but effervescence compounds such as certain hydrates lose water to the air. Hygroscopic compounds remove moisture from air, sometimes forming hydrates. Calculate the percent by mass of water in magnesium sulfate heptahydrate. So it would be the total mass would be the denominator, and the total mass of the water would be the numerator times 100. So that's 51%. How does a suspension differ from a solution? Well, a suspension has very large particles, greater than a micrometer, and it's not subject to the Tyndall effect, the solution, and it doesn't settle out. The particles in suspension are much larger and do not stay suspended indefinitely. What distinguishes a colloid from a suspension? and a solution, the suspension uniquely does not stay suspended. They fall out. Colloids have particles smaller than those in a suspension and larger than those in a solution. That's actually quite true. I'm not sure that I answered the question, but that's actually true. How can you determine through observation that a mixture is a suspension? The particles in a suspension will settle out over time. They will settle out over time. Could you separate a colloid by filtering? Absolutely not. That's one of the ideas of a colloid, is that it does not filter out. Particles in a colloid, such as gelatin, are smaller than the holes in filter paper, and cannot be removed by filtering. How can the Tyndall effect be used to distinguish between a colloid and a solution? The Tyndall effect is the kind of refraction and reflection of light rays through a medium, and the solution will not do that, but a colloid will. A beam of light is visible as it passes through a colloid and does not do it through a solution. What causes Brownian motion? Can the presence of a Brownian motion distinguish between a solution and a colloid? Yes. Brownian motion is a random motion. Brownian motion is caused by collisions of molecules of the dispersion medium from the small dispersed colloid particles. Flashes of light or scintillations are seen when colloids are studied under a microscope. Colloids scintillate because the particles reflecting the scattered light move erratically. The particles in a solution are too small to be seen under a microscope and do not cause scintillations. Again, there is a lab that can be done. I'll try to do that, but it's very smoky, and I don't want to set off any fire alarms. Why does water have high surface tension? Because of, hydrogen bonding. Because of hydrogen bonding, it has high surface tension. The water molecules form this netting. Strong hydrogen bonding causes an inward pull that tends to minimize the surface area. It's like walking on a net. It's the bonds create this netting throughout the water solution, and it holds everything together quite well. Why do the particles at the surface of a liquid behave differently from those in the bulk of the liquid? Why do the particles at the surface of the liquid behave differently from those in the bulk of the liquid? Surface molecules are attracted to the liquid molecules below, but not to the air above. So that's that. Describe what observable effects that are produced by the surface tension in a liquid. You form these rounded bubbles. It hurts a lot more to jump into cold water than warm water. Drops are spherical, objects denser, then a liquid can float on its surface. Very true. What is a surfactant? Explain how it works. A surfactant is a material that reduces hydrogen bonding within water. And that's about it. A wetting agent such as soap or detergent, a surfactant, interferes with hydrogen bonding between water molecules and reduces surface tension. So that's it. How can the unusually low vapor pressure of water be explained? Well, water molecules do not go in the air quite well. They don't go in the air very well, and so keeps the vapor pressure very low. Hydrogen bonds hold water molecules to each other, so the tendency for them to escape the solution is low. Explain why bodies of water with large surface areas, such as lakes and oceans, do not evaporate. Because water has a low vapor pressure. Water has a low vapor pressure, otherwise they would all evaporate. It would be really sad. How does the surface of ice differ from the structure of water? How does the surface of ice differ from the structure of water? Ice is regular open framework in hydrogen-bonded water, molecules arranged like a honeycomb. The structure collapses in liquid water. What would be some of the consequences if ice were denser than water? Well, all the marine life and lake life would die. Bodies of water would freeze from the bottom up. This would kill many forms of aquatic life. Explain the role of hydrogen bonds in ice. It forms this tetrahedron, physical bonded, kind of diamond-like quality. Hydrogen bonds between the water molecules hold the molecules in a regular open structure. I like my answer better. Distinguish between a solution in general and an aqueous solution. An aqueous solution is a water solution. A solution that has water as the solvent. Easy. So identify the solvent and the solute in a solution of table sugar. Table sugar is a solute, water is the solvent. Water is the solvent. Why is water an excellent solvent? For most ionic and polar covalent compounds, but not for nonpolar compounds. Polar water molecules electrostatically attract ions in polar covalent bonds, but nonpolar compounds are unaffected because they have no charges. Suppose an aqueous solution contains both sugar and salt. Can you separate either of these solutes from water by filtration? No. The molecules and ions are far too small, are smaller than the pores of the filter paper. Describe the process of solvation. It's the surrounding of the ions by the water molecules. Cations and anions become surrounded by solvent molecules. Cations and ions become surrounded by the solvent molecules. Which of the following substances dissolve appreciably in water? Give reasons for your answer. HCl, absolutely. Very polar, and it dissolves quite well. Sodium iodide, yes, because it's ionic, absolutely. Hydrogen chloride gas is a covalent substance. Ammonia will dissolve because it's very polar. It has that unpaired electrons above the nitrogen. Magnesium sulfate, yes, it's very ionic and it will dissolve. E is going to be methane, very organic from prehistoric plankton, nonpolar, will not dissolve. Calcium carbonate, ionic, but it's not going to dissolve. It's weird. It will not dissolve, thank God, because all the little arthropods wouldn't be alive. Explain why gasoline does not dissolve in water. Because it's not polar. Very not polar. And water is polar. Water is polar and gasoline is not polar. Like dissolves like. That's not just a clever expression. What particles must be present in a solution if it is to conduct electricity? Electrolytes, ions. 39. Why does molten sodium chloride conduct electricity? Because the ions can move. They're not bound in the crystalline state. The ions can migrate from one pole to the other, depending upon what ion, positive or negative ion. Its ions are free to move towards the appropriate poles. What is the main distinction between an aqueous solution and a strong electrolyte and an aqueous solution of a weak electrolyte? A strong electrolyte is almost totally ionized or dissociated. Water does not conduct electricity. What is meant by a substance's water of hydration? It's the water crystals that are bound to the water molecules that are bound to the crystalline structure of the substance. And it's represented by a dot H₂O. Write the formulas of these hydrates. Write the formulas of the hydrates. Sodium sulfate decahydrate, that would be N2SO4 dot 10H2O. CaCl2 dot 2H2O. Next would be BaOH with a 2 dot 8H2O. Barium hydroxide. Name each hydrate. Tin 4 chloride pentahydrate. Oh, at least I still know what I'm doing. Iron 2 sulfate heptahydrate. Greek prefixes, you're using Greek prefix. Barium bromide tetrahydrate. And I'm not sure there's going to be any more here. All right. Iron 3 phosphate tetrahydrate. Very good. This is kind of chapter 9, ladies and gentlemen. Make sure you know this for your exam. Epsom salt changes to a monohydrate form at 150 degrees. Write an equation for this change. So you're going to give up, per mole of hydrate, you're going to give up 6 moles of water. So, and that's Epsom salts. The magnesium sulfate is Epsom salts. Explain why a hygroscopic substance can be used as a desiccant. Well, you're using the anhydrous form, and it just absorbs water when you put it into the desiccator, and it just sucks the water out of air. 46. Why is it important to keep some hygroscopic substances in tight, sealed containers? Because they'll absorb water from the air, and they get really moist, like flour. Many of the grains will absorb moisture. Water, grains will naturally absorb water because it wants to germinate. Some hydrates are efflorescent. Explain what that means. Under the conditions, will a hydrate effloresce? Efflorescence is the loss of water of hydration that occurs when a hydrate has a higher vapor pressure than that of the water vapor in air. How can you distinguish between a suspension and a solution? Just wait, and the suspension will settle out. A suspension has larger particles that will settle to the bottom. The particles in the solution stay suspended. Arrange colloid suspensions and solutions in order of increasing particle size. Solutions, colloids, and suspensions. It was easy. Very basic, should be very, very basic to everyone by now. What is the Tyndall effect? Scattering of visible light by colloids and by suspensions. Scattering, diffraction, refraction. Why don't solutions demonstrate the Tyndall effect? Because the particles are less than 1 nanometer. They're very small, very, very small, and very little surface area to reflect. What causes Brownian motion? The movement of the particles. They're large enough to reflect light, so you can see them. Collisions of molecules of the dispersion medium with small dispersed colloidal particles. What are 2 circumstances that help keep colloidal particles in suspension? Brownian motion and repulsion between like charges, charged ions absorbed on the surface of the colloidal particles. How can a colloid be destroyed? By clumping. When they're attracted, the anions with a charge opposite to that of the colloid particles, and they clump, they kind of stick together. What makes a colloid dispersion stable? By adding an emulsifier. Which creates micelles and things like that that keep the particles suspended. From your knowledge of intermediate forces, arrange these liquids in order of increasing surface tension: water, hexane, ethanol. Hexane, ethanol, water. Hexane is completely organic, no hydrogen bonding at all. The ethanol has an OH in the water, as you know. Water has its maximum density at 4 degrees Celsius. Discuss the consequences of this effect. Water molecules have maximum density of 4 degrees Celsius. Below 4 degrees Celsius, the molecules are arranged in a regular network because of the attractions between them. As a result, ice has a lower density than water. Ice has a lower density than water. The graph below shows the density of water over a temperature range of 0 degrees Celsius to 20 degrees Celsius. Okay, bring it on. All right, so what? So you can see at 4 degrees Celsius, it's least dense, so it's going to float. What is the maximum density of water? 4 degrees Celsius, right from the graph. You can see that the water is highest then. 1 degree, what is the highest? What is the maximum density? 1 gram per milliliter. At what temperature does the maximum density of water occur? 4 degrees Celsius. Sorry, I got a little confused there. It happens at 4 degrees Celsius. Next, C, if there is a C. Okay. What would it be meaningful to expand the smooth curve of the graph to the left to temperatures below 0 degrees Celsius? It's actually, the graph is on the right. I had moved it. No, the density of ice is 0.917 grams per milliliter at 0 degrees Celsius. There would be a break in the curve at 0 degrees Celsius as liquid water at 0 degrees Celsius changes to ice at 0 degrees Celsius. Explain which properties of water are responsible for these occurrences. Water in tiny cracks in rocks helps break up the rocks when it freezes. Water expands when it freezes. Thaws, freezes, and then you finally make the crack bigger. Water beads up a newly waxed car. Surface tension, hydrogen bonding. Water is polar and wax is nonpolar, and water has a high surface tension. A longer time is needed for a teaspoon of water to evaporate than a teaspoon of alcohol. Low vapor pressure of water is much lower than alcohol. Alcohol has a higher vapor pressure. Describe what might happen if you put a sealed glass container full of water into the refrigerator. The container would break because water expands as it freezes. Crack the glass. Water is a polar solvent. Gasoline is a nonpolar solvent. Decide which compounds are more likely to dissolve in water and which ones are more likely to dissolve in gasoline. Okay, here we go. Carbon tetrachloride, gasoline, very, very nonpolar. Sodium sulfate, water, very ionic. Methane, gasoline, ionic, very, very organic. Potassium chloride, water, ionic. Notice I didn't say that carbon tetrachloride was organic. It's just very nonpolar. Explain why ions become solvated in aqueous solution. Anions are attracted to the hydrogen atoms of the water molecules because they have a partial positive charge. Cations are attracted to the oxygen atom in the water molecule because they have a partial negative charge. Here I did 63 and 64 without making separate slides, so let's get started. You have a solution containing either sugar or salt dissolved in water. Can you tell which it is by visual inspection? Absolutely not. They both dissolve in water. Give 2 ways by which you could easily tell which is which. Drying and examine the crystals, testing for electroconductivity. doing a flame test. Remember, sugar is not an electrolyte, very important. Explain why ethanol will dissolve in both gasoline and water. Ethanol has both a polar hydroxyl end that dissolves in water and a nonpolar hydrocarbon or organic end that dissolves in gasoline. Remember that OH, that hydroxyl group, has a lot of hydrogen bonding. Are all the liquids soluble in each other? Explain. Are all liquids soluble in each other? No. Nonpolar molecules do not dissolve in polar solvents. Are all liquids soluble in each other? No. Some are polar, some are nonpolar. Nonpolar doesn't dissolve in polar, and vice versa. Write equations to show how these substances ionize or dissociate in water. This would be just simply break down into NH4 plus and Cl minus. In aqueous, AQ means aqueous. This would be copper 2 nitrate, would be copper plus 2, and nitrate 2 copper plus 2, and then nitrate negative 1. This would be acetic acid, H plus, and then C₂H₃O2 minus 1. Very straightforward. And that's acetic acid or vinegar, the operative thing in vinegar. This is mercury 2 chloride, a weak electrolyte, Hg plus 2 and 2 Cl minus 1. So that's going to break down into what's there. Name these hydrates and determine the percent by mass of water in each. This is going to be Na2CO3 dot H2O. That's going to be sodium carbonate monohydrate. Now just remember, I'm going to say this once more. You take the mass of, so it's 2 times sodium plus 1 times carbon plus 3 times oxygen, so that's going to be 46 plus 12 plus 48 plus 18. That's the total mass of that particle. And then take the water 18 divided by that total mass times 100, and that's going to be the percent by water, the percent of that molecule that is water. Okay, so that's how you do that, and I'm going to be doing all of these very quickly, and I'm not going to be stopping to actually do the calculations, but you are responsible for those calculations and doing them in good measure on separate paper. Sodium carbonate monohydrate, 14.5% H2O. Magnesium sulfate heptahydrate, and that'll be 51.2% of water. How many grams of copper 2 sulfate pentahydrate would you need to measure in order to have 10 grams of anhydrous copper 2 sulfate? 15.6 grams copper 2 sulfate. 15.6 grams copper 2 sulfate. Now remember, the copper 2 sulfate pentahydrate is blue. It's a beautiful dark blue crystal. And then the anhydrous form is going to be a white powder. And when you put the water back in, it's very exothermic. A hydrate has the following percent composition: 75.5% calcium chloride and 24.5% H2O. What is the formula for this hydrate? CaCl2.2H2O. Match each term with the following descriptions. A description may apply to more than one term. Okay. 1. Does not settle out on standing. 2. Heterogeneous mixture. 3. Particle size less than 1 nanometer. 4. Particles can be filtered out. 5. Demonstrates Tyndall effect. 6. Particles are invisible to the unaided eye. 7, homogenized milk. Salt water is number 8. And 9 is jelly. 9 is jelly. A, solution. Let's see. Well, 1 does not settle out on standing. That's true. 3, particle size less than 1 nanometer. That's absolutely true. 6, particles are invisible to the unaided eye. Absolutely. And salt water is an example. Absolutely. Well done. B, a colloid. Heterogeneous mixture. Number 2, right off the bat. Number 1, does not settle out on standing. That's actually quite true. Particles can be filtered out. Absolutely not. They cannot be filtered out. Demonstrates Tyndall effect. Invisible. They can be invisible to the unaided eye. Not always. 7, homogenized milk. Obviously not unaided, not invisible. And number 9, jelly is also a colloid. Jelly is a colloid. Suspension. Suspension. What are the things about this suspension? Number 2, heterogeneous mixture. Number 4, particles can be filtered out. That's very true. Demonstrates the Tyndall effect. When ethyl alcohol dissolves in water, the volume of the final solution is less than the separate volumes of the water and alcohol added together. Can you explain this result? Well, yeah, there are gaps between the molecules in each of the liquids. The hydrogen bonded structure in water disrupted by the ethyl alcohol when ethyl alcohol is added, because the alcohol competes for hydrogen bonds with the water molecules and the water structure collapses. Thus, the mixtures of water and ethyl alcohol have less volume than the sum of the volumes of the components. Describe what would happen to a pond at 0 degrees Celsius if the density of the ice were greater than the density of the water. Do you think the pond would freeze more quickly? Well, yes, it would freeze more quickly. Ice would form on top and sink to the bottom. The pond would freeze more quickly because no surface ice would insulate the water below from the freezing air. There are other things too involved there. When humidity is low and the temperature is high, humans must take in large quantities of water or face serious dehydration. Why do you think water is so important for the proper functioning of your body? Well, because most of the important chemicals, chemical reactions in life take place in aqueous solutions inside the cell. You have electrolytic materials that travel in the water and that go in and out of the cell. Describe as specifically as possible what would happen if a nonpolar molecular liquid were added to water. What would form if you shook this mixture vigorously? The liquid would form a layer on the top of the water if the density were less than that of water, and at the bottom if the density were greater. The mixture would form a temporary emulsion. Why is the midday sky blue while the evening sky in the west is often an orange or red color? Well, this is specific to the East Coast, but that's because the sun is setting it's setting through a larger collection of molecules. It also works generally in high pressures, but the sunlight is scattered by the particles in the atmosphere. The shorter wavelengths of the visible light, blue and violet, are more visible at midday when the sun is closer to the earth. The longer wavelengths of visible light, yellow and red, are more visible at sunrise and sunset when the sun is at its greater distance from earth. But a lot of it has to do with the thickness in which the sun is shining its rays through. In the evening, when it's setting in the west, it's coming through a thicker layer of molecules. And if it's high pressure, it will be more oxygen and nitrogen and less water. The water, it doesn't, you don't have that same effect. Make a drawing to show how oxygen atom in one molecule of water can be connected to as many as 4 other molecules of water by hydrogen bonds. Write an explanation of your drawing. Well, this doesn't show you the angles, but you're forming literally a tetrahedron by these 4 physical bonds. A problem for firefighters is that much of the water they spray on a fire doesn't soak in, but runs off carrying debris and pollutants into the environment. Explain how the addition of a surfactant to water used to fight fires could help put out the fire more rapidly and protect the environment. Well, the water, it would be more efficient, for one thing, because it would do more wetting. The surfactant helps to wet the burning material so less water rolls off carrying pollutants into the environment. So it has to do with a more efficient way of doing things, the surfactant. When spring comes, ice melting at the surface of a pond begins a beneficial process that stirs up the water of the pond. Explain why the pond water begins to mix when the ice melts. In spring, when the ice melts and the temperature of the surface water increases to 4 degrees Celsius, it becomes heavier than the water below and sinks. The upward movement of the surface water forces water in the deeper parts of the lake upward, where it is warmed. And then you get that suspension of muddy water, quite dramatic. After a winter of alternate periods of freezing and thawing, some roads have broken pavement and potholes. Using what you know about the properties of water, explain why potholes form. Water enters cracks in pavements and expands when it freezes, creating larger cracks. Continuous freeze-thaw cycles cause pavement to actually break up quite significantly. What relationships exist between the following volumes? 1 gram of ice at 0 degrees Celsius and 1 gram of liquid water at 0 degrees Celsius. Well, in order to melt ice at 0 degrees Celsius, it has to absorb 80 calories per gram. The volume of 1 gram of ice at 0 degrees Celsius is greater because the ice expands. You also have other things involved. 1 gram of liquid water at 100 degrees Celsius and 1 gram of steam at 100 degrees Celsius. Again, there's a density situation going on here. There are other things involved, such as heat of vaporization as well, but this is talking about density. The volume of 1 gram of liquid water at 1 degree Celsius is less. The volume of 1 gram of water is less. When that turns into vapor, the volume is going to be much greater, much greater. Cobalt chloride test paper is blue. This paper is made by soaking strips of paper in an aqueous solution of copper chloride hexahydrate. The paper strips are then dried in an oven, and you literally drive off that hexahydrate as a result of this drying process. And here's the equation, which shows that you're adding the heat and you're creating that per mole, anyway, of the hydrate, you're producing 6 moles of water. When cobalt 2 chloride hexahydrate is dissolved in water, what is the color of the solution? What is the color of the solution? So now you're going to be testing for water. You're going to be actually testing for water. And when it turns pink, it means that water is around somewhere. Obviously, it's all through it, but this type of paper can be used to search for water. What is the color of wet cobalt chloride paper? What is the color of wet cobalt chloride paper? Well, if you look at A, you can see that it's pink. It turns pink when it's going to be in the presence of water. So you can test for water using this kind of paper because the cobalt turns pink. What is the color of dry cobalt chloride paper? Well, it was pink and now it's blue. So it turns between pink and blue. It says cobalt chloride test paper is blue. It's blue when it's dry. When you drive the water off, it turns blue, such as in the equation. Okay, and I think that might be it for that. Let's see. Oh, we have one more. What is the percent by mass of water in hexahydrate? Well, you would take, again, the entire weight of cobalt chloride hexahydrate, and then that's the numerator, that's the denominator, and then 6 moles, 6 times 18 would be the numerator, times 100, and you get 45.4%. 45.4% of water. What does cobalt chloride test paper test for? It tests for the presence of water. Fairly simple problem for 81. You would think that it would get more difficult than this. Water or water vapor. A cylindrical vessel 28 centimeters in height, 3 centimeters in diameter, is filled with water at 50 degrees Celsius. The density of water is 0.988 grams per cubic centimeter at this temperature. Express the mass of water in the vessel in the following units. Now remember, mass is density times volume. Volume is 28, height 30 squared pi, pi r squared h. So it'll be 28 times 3 squared times pi times 0.988 grams per cubic centimeter. Now I've got to express that in various ways. For instance, grams. It'll be 195 grams. It'll be 195 grams because that mathematical equation, pi r squared h times d, or density, 0.988, would be 195 grams, or 195,000 milligrams, because you simply move the decimal point over 3 places to the right. Each gram is going to be 1,000, so it'll be 1.9 times 10 to the 5th milligrams, or 195,000. It has the magnitude of 5. And then we're going to express it as kilograms, and that would be 195 divided by 1,000, and that would be 0.195 kilograms, 0.195 kilograms. And just remember, it's pi r squared h times 0.988, so it's 28, times 3 squared, which is 9, times pi. So pi times 9 times 28 is going to be 195 grams. How many significant figures in each measurement, in each of the following measurements? So 56.003 grams would be 5, and then 750 would be 2. That 0 is not significant. 0.0056 would be 2. And then 0.4005 would be 4. And then this is a review if we haven't figured it out yet. Write a correct electron configuration for the oxide ion, which noble gas has the same as neon because it's adding 2 electrons, so it's going to be 1s2, 2s2, 2p6. When a proton is attracted to the unshared electron pair of the water molecule, the polyatomic hydronium ion is formed. Draw the electron configuration structure, the electron structure, to show the formation of this ion. You're simply going to add to an unbonded pair hydrogen, and that'll be a +1 charge. If you did the math, you'll find that it's +1. And then this next one, the balloons contain 1 mole of helium, methane, and oxygen at STP. So they're going to ask you things like, what is the volume of each balloon? It's going to be 22.4 is going to be the volume of each, 22.4, because it's all 1 mole, so it'd be 22.4 liters. And then what is the mass of each balloon? It'll be 16 for 4 for helium, 16 for methane, and 32 for oxygen. And then it would be calculate the density of each balloon. So it's going to be the mass divided by 22.4. You could work that out yourself, and those are the answers there for helium, methane, and oxygen. It would just be the mass divided by 22.4 liters. The density of air at room temperature is about 1.2 grams per milliliter. Balloons containing helium and methane will rise. Oxygen balloon will sink because of the densities. Balance these equations. So the first equation will be, let's see, CO2 plus H2O yields glucose and oxygen. So why don't you balance them? So it'll be the coefficient 6619. 6619 will be the coefficients. And then sodium plus water, and those are the ions. It'll be 1, 2, 1, 2, 1. So that's kind of an interesting one to balance. How many grams each of hydrogen gas and oxygen gas are required to produce 4.5 moles of water? There's the equation, the balanced stoichiometric equation. You know it's going to be 32, 4, and 36. Up top, those are going to be the values. But I just need to do oxygen and hydrogen, 32 and 4. And then I'll do 36 too, but I don't think I need to do that. How many grams of each to produce 4.5 grams of moles of water? Yeah, so I'll need to do water as well. So it'll be water is to water. 2 moles of water is to 2 moles of water, as 2 moles of water is to 4.5 moles of water. So that'll be 36 grams is to 2 moles, as how many is to 4.5 moles? So that's going to be 81 grams of water. Now we're going to compare the hydrogen with the water. So 2 moles of hydrogen over 2 moles of water is 4 over 36. And then that's going to be X over 81. So how much hydrogen am I going to need to make 81 grams of water? And the answer will be, solving for X, and that'll be 9. So I need 9 grams of hydrogen. Now, how many grams of oxygen will I need? Well, 81 minus 9 would be 72. So I would need 72 grams of oxygen. 81 minus 9 is 72. That's how much oxygen I need. So I need 72 oxygen and 9 hydrogen in order to get the job done, as the problem is written. The composition of hydrogen peroxide is given by the following equation. So it would be 2 peroxide molecules yields 2 water plus 1 oxygen, gas and liquid, etc. So that's the equation for the decomposition of hydrogen peroxide. Calculate the mass of water and the volume of oxygen at STP formed when 2 times 10 to the negative 3 moles of hydrogen peroxide is decomposed. 2.00 times 10 to the negative 3 moles of hydrogen peroxide. There's the equation again for the decomposition of hydrogen peroxide. 68 grams of hydrogen peroxide is going to yield 36 grams of water in a liquid state and 32 grams of oxygen. Now, let's do the problem. We have 0.002 moles of peroxide, and the mole ratio is 1 to 1 for peroxide and water, and then it would be 0.001 moles for oxygen because it's 2 to 1, water to oxygen, and that's going to be 0.002 moles, going to be 34 grams, okay, and that'll be 18 grams, 0.002 moles, and then 32 grams. That's what we're saying, okay? And then I'm going to convert that, and I'm going to convert that to 0.068 grams. So in other words, I'm multiplying 0.002 times 34 grams, 0.002 times 18 grams, and 0.001 times 32 grams. So I'm getting 0.068 grams, 0.036 grams, and 0.032 grams. So in terms of moles times mass, and that's what I'm getting for those values. That's where those values are actually coming from. And I just did that with mole ratios. Calculate the mass of water produced in the complete combustion of 8 liters of propane at STP given this unbalanced equation. Well, I will have balanced the equation already, so that's the balanced equation. I'll put my stoichiometric masses in there. And I know that if I begin with 8 liters of propane and the mole ratio is 1 to 4, I'm putting in the stoichiometric masses, so let that happen. So 1 is to 4 as 8 is to what? So it's going to be 32 liters of oxygen. Well, I'm sorry, 32 of water. 32 liters of water will be produced with 8 liters of propane. Well, how many moles is that going to be? Well, 1 mole is 22.4 liters. So how many moles is 32 liters going to be? So that's the first thing I'm going to want to do. I want to find out how many moles of water will be produced. And then it's simply the number of moles times 18. So it's 8 liters of propane, and you can see that it's going to be 1 to 4 is the mole ratio. So it's 1 to 4, so it'll be 4 times 8 is 32 liters of water. Now, if it's 32 liters of water, and each mole is 22.4 liters, so it'll be 32 liters divided by 22.4 liters is going to be 1 point something moles. Now, 1.43 moles. So 1 mole is 18 grams. Well, all right, fair enough. What's 1.43? So 1.43 times 18 is going to be 25.7 grams, and that will be the final answer. Acetaldehyde is produced commercially by the reaction of acetylene with water as shown by this equation. That's the equation, and it is balanced as it's written. How many grams of C₂H₄O can be produced by 240 grams of water, assuming sufficient acetylene is present? Well, there are the stoichiometric masses. That's very quickly done. So you should be able to go to that point. So the constant ratio is acetaldehyde over water. So it will be the mass of acetaldehyde over the mass of water as written in the equation. So it will be 44 over 18 equals X over 260, and that will give you the amount of acetaldehyde that can be produced given sufficient quantity of acetylene. So the answer is 636 grams of acetaldehyde given 260 grams of water and a sufficient amount of acetylene. Next, a mixture of 40 cubic centimeters of oxygen and 60 cubic centimeters of hydrogen gas at STP is ignited? A. Which gas is the limiting reagent? What is the mass of the water produced? Which gas remains after the reaction? And what is the volume at STP of the remaining gas? So, you need to find out the limiting reagent before you can find out the mass of water produced. The limiting reagent is not the excess reagent. The excess reagent is therefore the other reagent. And then you need to find the other reagent, the reagent that's in excess, before you can determine the volume of that remaining gas. So the reaction 2H2 plus O2 yields 2H2O is going to be the balanced stoichiometric equation. The next thing we're going to want to do is we're going to want to begin to write the masses of each quantity above them as we normally do. However, this time we're going to be looking at, we have 60 cubic centimeters of hydrogen and 40 cubic centimeters of oxygen, but these aren't stoichiometric masses. These are the volumes that are given in the equation, so don't confuse the two ideas. 60 cubic centimeters of hydrogen and 40 cubic centimeters of oxygen. And according to the reaction, if I have 60 cubic centimeters of hydrogen and 40 cubic centimeters of oxygen, which one am I going to produce? Well, if oxygen were used, 80 cubic centimeters of hydrogen would be needed. So hydrogen, it must be limiting and should be used to answer other questions in the problem. So, because the hydrogen to water is 2 to 2, or 1 to 1, I'm going to produce 60 cubic centimeters of water. So that's going to be the answer to that part of the problem. So we've now established that hydrogen is the limiting reaction. So now we have to determine what volume, what mass of water is therefore produced. So we've got to figure out, all right, well, here's the reaction. What's 60 cubic centimeters of hydrogen equal to in terms of a mass? So we have to convert that mass, that volume, 60 cubic centimeters, to liters to determine the moles. So what do we do now? We know that 60 cubic centimeters of hydrogen is going to produce 60 cubic centimeters of water. That's easy. So now what do we do? So what's the next step? Well, that's going to be 0.060 liters of hydrogen is actually going to react. And that's going to react with 0.03 liters of oxygen and produce 0.06 liters of water. So now if I convert the 0.06 liters to moles by dividing through by 22.4 liters, I'll determine the moles of each. So I know the volume of each, now I want to determine the moles of each. So the moles of hydrogen will be 0.00268 moles. So half of that will be the moles of oxygen, and it'll be 0.00268 moles of water. So 0.00268 moles of hydrogen translates to 0.00536 grams of hydrogen. So 0.00268 moles of hydrogen translates to 0.00536 grams of hydrogen. So what I did was I multiplied 0.00268 moles times the mass in grams of 1 mole of hydrogen, and that will give me 0.00536 grams. So now I have my constant ratio of 2H2 to 2H2O. I know the mass of hydrogen. Now I can find the mass of the water. So my constant ratio is 4/36, and that's going to equal 0.00536 over x. So 4 is to 36 as 0.00536 is to x. And now solve for x, and that will give me the mass of water that I will produce. Okay, so that's pretty straightforward. Now remember, that's 0.048 grams of water. Now remember, we still have to work on the oxygen. How much did I actually need of that oxygen and how much is left over? That's the next step in this problem. So there's the 0.048 grams of hydrogen, and now I want to use the values to come up with. There's the 0.048 grams of water produced, and I need to I know that oxygen remains after the reaction, and I need to know the volume. Like, I know what volume I used. I used 30 cubic centimeters because it's 60. It's 2 to 1, or 60 to 30, the volume. So I use 30 cubic centimeters of oxygen. Do you see that? So 2 is to 1, as 60 is to what? And that'll be 30. So I used 30, so oxygen is remaining. And what is the volume remaining? So it should be 10 cubic centimeters of oxygen given those ratios. Let's review the problem. We used 60 cubic centimeters of hydrogen, and we started off with 40 cubic centimeters of oxygen. If we used all the oxygen, 40 cubic centimeters, we would have needed twice that because the mole ratio of hydrogen to oxygen is 2 to 1. But we don't have 80 cubic centimeters of hydrogen, we only have 60. So the hydrogen must have been the limiting reagent, and we converted that to a mass, and then we found the mass-mass relationship, and we found the mass of the water, which was 0.048 grams. Now, the gas remaining was obviously oxygen. Well, if I use 60 cubic centimeters of hydrogen, and the ratio is 2 to 1, hydrogen to oxygen, I only use 30 cubic centimeters of oxygen. I started with 40. 40 minus 30 is 10. 10 cubic centimeters. 10 divided by 1,000 is 0.01. So I have left over 0.01 liters of oxygen, and that completes the problem. Explain how the following changes in the pressure on the surface of water affect the water's boiling point. So we're going to look at pressure and boiling point. Okay, an increase in pressure, that's going to increase boiling point, because the higher the atmospheric pressure, the higher the vapor pressure, the higher the vapor pressure, the higher the boiling point. So it's going to raise the boiling point, and that's what we predicted. A decrease in pressure, the opposite will happen. It's going to lower the boiling point. It's going to lower the boiling point. The temperature of 1 liter of steam at constant volume and 1 atmosphere pressure is increased from 100 degrees Celsius to 200 degrees Celsius. Calculate the final pressure of the steam in atmospheres assuming the volume does not change. Gay-Lussac's law. Now make sure that you convert to Kelvin, and then you simply plug in. You plug in. What's going to happen? Well, we're going to have 1 over 273, and then what pressure over 373? So it's going to be 1 times 373 divided by 273 will equal the new pressure, and that will be, again, 1 atmosphere times 373 Kelvin divided by 273 Kelvin is going to equal, on your calculator, P2 will equal 1.37 atmospheres. The unit test. When a sugar cube completely dissolves in a glass of water, it forms a colloid, suspension, emulsion, solution, and the answer is a solution. How many water molecules are tied up in a formula unit of a compound of octahydrate? 9 octahydrate. 9, 8, 7, 6. Well, the answer is 8. I hope you know your Greek prefixes. Which property is characteristic of water? Relatively high surface tension, relatively high vapor pressure, relatively low solvent ability, relatively low polarity. And the answer is relatively high surface tension. Why do distilled water and the ethanol solution have 0 conductivity? When water is purified by distillation, dissolved ions are removed. Ethanol is a molecular compound that does not ionize water. Explain why 2 pairs of conducting solutions have similar conductivities. Potassium chloride and sodium hydroxide have similar conductivities because they each provide 2 moles of ions per mole of compound. CaCl2 and MgBr2 have similar conductivities because they each provide 3 moles of ions per mole of compound. The aluminum chloride solution has a conductivity that is about twice that of potassium chloride solution. Explain. Aluminum chloride provides twice as many ions per mole as potassium chloride does. Atomic window A represents solute particles in a given volume of solution. Which window represents the solute particles in the same volume of solution when the amount of solvent is doubled? A, B, C, or D? Which one is it going to be? I'm going to double the solvent, and I'm going to reduce the concentration as a result of that. Use the description below and the data table in the next column to answer questions 4 to 6. A student used conductivity meter to measure the conductivity of several aqueous solutions. The magnitude of the conductivity value is proportional to the number of ions in solution. This SI conductivity unit is the microsiemens, or S/cm. The table gives the results reported by the student who tested 6 solutions plus distilled water. Each solution had a concentration of 0.02 molar. For each question there are 2 statements. Decide whether each statement is true or false. Then decide whether statement 2 is a correct explanation for statement 1. Water has a relatively high surface tension because water molecules form strong hydrogen bonds with other water molecules. Methanol is strong electrolyte because methanol molecules can form hydrogen bonds with water. Particles in a colloid settle out faster than particles in a solution because particles in a colloid are larger than particles in a solution. And then the last one, water molecules are polar, and that is because the bond between hydrogen and oxygen atoms in water molecules is polar. It has more to do with the geometry, but fair enough. 8, let's see. 8 is true. 8 is true. Water has a relatively high surface tension because water molecules form strong hydrogen bonds with other water molecules, and that's also true, and it's a correct explanation. Methanol is a strong electrolyte because methanol molecules can form hydrogen bonds with water. So let's see, that's kind of false. It could be because the oxygen will form hydrogen bonding, but methanol molecules can form hydrogen bonds with water. That's right, but it is not a strong electrolyte. Number 10, particles in a colloid settle out faster than particles in a solution. That is false because particles in a colloid are larger. Yes, that's a correct explanation, but not to that particular statement. That is true, they are larger. And then number 11, water molecules are polar. The bond between hydrogen and oxygen atoms, the water molecule. I would say, I think what the book's going to say is that's true, but it is true, but it's really because the molecule is polar because of the geometry. So I do not agree with the book, and I do not believe that's a correct explanation. I believe that the water molecules are polar because, not because of polar bonds. Methane has polar bonds, but the molecule in itself, everything cancels, and the molecule in and by itself is nonpolar. And that concludes the book problems. Hope you did well, and hope you're ready for the test come next week.